Welcome back from the break. We're now going to move into our second session, which is looking at 3 practical applications of the SWI and SSM Copernicus products. First of all, we have Dr. Riccardo Dainelli from the Institute of Bioeconomy National Research Council, and then following on from that, Fernando Roque from Quantic Statistics in Guatemala, and finally, Anisora Irimescu from the National Meteorological Administration in Romania. We will be collating questions at the end of the third presentation. So if you've got a question, please make sure you go to the meet.ps/JNCC soil section during these presentations. If there's a question particularly for one of the speakers, can you please indicate that in your question when you pose it? And now I'm very pleased to, I'll just stop sharing my presentation. So thank you. I'm now very pleased to introduce Dr. Riccardo Dainelli to talk about open big data and precision agriculture in the AgraStat project.
Thank you, Lynn. Do you hear me?
Yes, I can.
Okay. And do you see my presentation also?
Yes, it's in presentation mode. Thank you.
Okay, I can go. So, good afternoon, everybody. I'm Riccardo Dainelli, and I'm a research at the Institute of Bioeconomy, that is a part of the Italian National Research Council. I will briefly show you what our platform AgraStat is, and then I will get to the heart of the presentation by telling you how we use the Copernicus data to retrieve soil moisture. Oh. Okay. In 2017, in Italy, only 1% of agricultural land was managed through precision agriculture, far away from the European goal of 10%. However, in the last 3 years, the scenario is changed positively. In this context, AgraStat aims at facilitating the spread of precision agriculture by connecting academic research to end users. So AgraStat is an open source platform that tries to make the best use of Earth observation satellites data. Here you have a brief history of AgraStat. The idea was born in 2017, and the focus has always been on the herbaceous crops. Sorry for the thunder. The latest products released are the retrieval of soil moisture content and a tool for automatic recognition of plant diseases, which is still under construction. From the beginning, AgraStat has been characterized by broad interoperability. We use satellite data from Copernicus Hub, like sentinel scenes, weather data, and drought index. But we also use ground data, which are represented by weather observation provided by the regional weather station network. So here you can see the main products provided by AgraStat. In addition to the soil moisture content, we provide a true color image of the field. That is not shown in the slide. It's an DVI index, a forecast of the potential yield, and here in the bottom, a map for variable rate fertilization. Registered users have their dashboard where farming units can be monitored. The lower part of the picture, this one, represents the studio package where agrometeorological data are collected. Here you can see the expected timing of phenological stages for wheat according to the growing degree days. Let's go now to the core of the presentation. That is how we retrieve soil moisture content from Earth observation data. Let's start with the old method that we developed in 2018. So the first attempt was to elaborate a qualitative index named water crop condition, focused on crop water stress with 3 different levels, low, medium, and high, and with a resolution of 20 meters. The index was created starting from data fusion between the soil water index and Sentinel-2 scenes to combine high temporal resolution of the former with the high spatial resolution of the latter. We use band 8 and 11 of Sentinel-2 with 20 meters of resolution to calculate the normalized difference water index, which detects crop water stress. And we use also the soil water index with 12 kilometers of resolution acquired by the Copernicus Global Land Service, which quantifies the soil moisture. Referring to the soil layers that are present in the SWI, in the first phase, all the layers were evaluated. Then we used the T40 layer at an estimated depth of 25 centimeters. This slide reports the flowchart of water crop condition. Firstly, Sentinel-2 products are interpolated from 20 meters to 12 kilometers to reach the SWI resolution, and then we apply the mask to exclude rivers and other water bodies from the scenes. Then we calculate the regression coefficients that result from the correlation between SWI and NDWI, retrieved on the same daytime. In this way, we can estimate missing data, but without forgetting that the lack in the availability of SWI and Sentinel-2 scenes for the same day could reduce regression accuracy. Here you can see an image in the center in the light blue. There is a polygon drawn in AgraStat as an example of the index for a cereal field situated in Apulia, South Italy. And at the bottom of the picture here, you can see the bar with different levels of crop water stress. That is qualitative information. Let's make some consideration of this method. First issue, from the farmer's point of view, the index is not fully understood. And in general, the index has both spatial and temporal high resolution, but the computing time procedure is time consuming. Moreover, if some Sentinel-2 scenes are missing due to cloud cover, especially in between March and May, that is a crucial period for crops like wheat, the discrepancy between SWI and the crop phenological stage rises. This fact is quite negative because the gap can limit the functionality of AgraStat, considering that the target crops are cereals. For this reason, this index was abandoned. The new product, elaborated in 2020, is a spot product characterized by a high spatial resolution, and therefore it allows to retrieve a quantitative measure of soil moisture. The native resolution of 10 meters for Sentinel-2 scenes is maintained, except for band 12, so the computing time is reduced. Just for example, we can elaborate all the national territory of Italy in about 1 hour. And the value stemming from this model is deeply linked to soil moisture and is not an index. In the first phase, we used a linear model taken from the literature, namely the optical trapezoid model, OPTRAM. And we surveyed soil moisture directly in fields, both with spot and long-term measurements. The experimental design comprehends both rain-fed and irrigated fields situated in the north and the center of Italy, and cropped with corn, wheat, and pastures. The raw input data are Sentinel-2 band 4, 8, and 11, and reflectance values from bands 4 and 8 were used to calculate the normalized difference vegetation index, NDVI, and the reflectance from band 12 was used to calculate the short-wave infrared transform reflectance, STR. In the second approach, a nonlinear model is built by our research group. The nonlinear trend is more visible in the right panel, where the STR NDVI scatter plot is represented between the dry edge, red line, and wet edge, blue line. So soil water content, W in the equation, is derived by combining the NDVI and the STR, which are a measure of health and vigor of vegetation. Here the comparison between measured and estimated soil moisture is reported. As we can see, there are slight improvements with the nonlinear model. For example, the regression coefficient goes from 0.73 to 0.80. Moreover, the 10 meters resolution product shows a strong linkage with the modeling reconstruction, confirming the worth of the qualitative value. This picture demonstrates how the nonlinear model is capable to recognize soil moisture variation, as we can see in the top left panel of the picture, that shows the beginning of irrigation in blue for a rotating pivot system. This irrigated area with a diameter of 1 kilometers can be easily compared with the 1 pixel of Copernicus soil surface moisture product. Here we can see a broad comparison among soil moisture in situ, red line, our estimated values, white square, and SSM Copernicus products, gray circles. The analysis is carried out in the same irrigated field of the previous slide, and the peaks of red line here represent the passages of the rotating pivot system, irrigation system, while the daily rainfall is also reported in blue lines. In general, Copernicus SM underestimates the soil moisture, while often overestimates it after rain days. Overall, the nonlinear optimum values show a good performance, but they are lacking in temporal resolution. Indeed, as you can see, there are only 9 dates available for a period longer than 2 months versus 24 for Copernicus SSM. In this last slide, the case study for AgraStat soil moisture is presented. We drew a polygon over a field cultivated in 2020 with rain-fed durum wheat. The field has slight slope about 3% towards the side along the highway, so descending in this way. For this reason, water stagnation is not excessive but constant after every rainfall event. Let's analyze the time-lapse change of soil moisture with the help also of the diagram at the bottom that reports the daily evapotranspiration, black histograms, the cumulative evapotranspiration, red line, sorry for the thunder, and the cumulative rainfall, blue line. On the 13th of March, soil moisture is around 0.3, 0.4. And this value is quite low even if rainfall occurs, because the crop came out from a long, dry winter period. On March 18, there is a shift of the water in the soil towards the upper parts of the field according to the slope, while in the lower part, soil moisture slightly decreases because no rainfall occurs and because of moderate evapotranspiration. On the 2nd of April, there is an increase of soil moisture in the bottom part of the field, following a heavy rainfall event and quite low temperatures. On April 27, we can note a widespread and marked increase of soil moisture after 2 May rainfall events. On the 22nd of May, there is another increase of soil moisture, especially in the lower part of the field, following a rainfall event that occurred on the same day of Sentinel-2 scene acquisition. Finally, on June 26, the crop is already harvested. There are no black histograms, and the soil is bare. There is a strong loss of water from the soil due to high summertime temperature and due to crop soil uncovering. So this is the accuracy through which AgraStat detects soil moisture. That's all, and I would thank the delegates and the workshop organizers. Thank you for allowing me to present our work, and this is our contacts.
Thank you very much, Riccardo, and finished beautifully ahead of time. Thank you, much appreciated. That helps my job. Right, brilliant. So next, I'd like to introduce Fernando Roque to talk about the drought impact on coffee plantations and biodiversity on both sides of the Pacific Ocean.
Hello, can you hear me?
Yes, Fernando.
Yes. Okay. Good morning. Thank you very much for your invitation. I'm going to present part of our work. I'm going to show you the results about the drought impact of coffee implantation and biodiversity on both sides of the Pacific Ocean. We are using the Copernicus Soil Water Index measures the impact of droughts on coffee plantations and biodiversity in two regions in Guatemala and in Vietnam highlines. So the objectives, one is that we are having problems with droughts and biodiversity loss are difficult conditions for agriculture. So these situations demands a better local and remote sensors to identify the most affected areas and to identify the most resilient regions to drought conditions, okay? So this is the index. We are going to see first a background of a problem, a serious problem that we have with El Nino in 2014. In 2014, then we are going to see a soil moisture during May because this is a very important at the beginning of the rainy season. It is critical for the coffee plantation and flower blossom. Then we are going to compare the soil water index level during the rainy season for Guatemala and Vietnam because we are both countries that we both have a very large regions of coffee plantations. So we are going to compare these two regions on both sides of the Pacific. And also we are
Fernando,
going to see yes?
May I just interrupt you? Your presentation is not on full screen.
Oh,
so
sorry.
You may need to stop sharing and then try sharing just the presentation, the application rather than your desktop. And then we'll be able to read all the detail on the slides. Sorry to interrupt.
Okay. Oops. Okay.
Not seeing anything yet.
Yep. You look in my screen?
I can see your screen, but it's not on slideshow view yet.
I am
you see
on
along
my.
the top?
Oops.
Can you start the slideshow? If you look on the top ribbon, you've got several options, transitions, animations, and then there's a slideshow view.
My entire screen. Okay.
We're still not seeing the slideshow. I think maybe we could use our backup presentation and Maddie. Oh, actually, I think you managed it now. Yep, we can see the full screen. Thank you. Sorry to interrupt. Please continue.
Okay.
Thanks.
Okay, sorry, yeah. So then I am talking about that we are having also a problem that El Nino right now, it is neutral, but the Pacific Ocean forms new atypical forms that cause droughts, and that's caused a very high problem with for us. And the present and future irregular rainy seasons creates the demand for soil moisture remote sensor indicators like soil water index to follow up the agricultural performance. So here it is my first, this is the slide where we measure 3 different regions that are with the El Nino affecting on from 2012 to 2016. We can see these 3 different regions. We have the Australia in blue, we have California in red, and also we have Coban, which is the northern region of Guatemala, and we can see that there is a low soil water soil water index for these years. Okay, so after this we have a serious problem because we are looking here on this chart, the northern coffee region of Guatemala, and we can see that for these 3 years from 2018 to 2019 and 2020, we are having that the rainfall for May, it is extremely low, and as I told you before, it is a very very high problem for the coffee plantation because it needs a high soil moisture for May to do a good flower blossom and to have a good crop. Okay, so this multi-year crisis probably was one of the causes of the mass migration of Guatemalans to the United States. You can see a full article of the press that on this link within the presentation. And also, we can see here another region in southern coffee region in Guatemala. Again, we can see the same problem that from 2018 to 2019 and 2020, we see that we have a low water index for May, and that's create another problem because we lost the May rainfall, so this is creating a very high problem for our coffee plantation. Now we can see again now for the other side of the ocean or in Vietnam, we see that they are struggling also with these droughts. I left you a link with an article from Daily Coffee News that the Vietnam coffee plantations are having the same problem, that the rainfall of May we are losing this that we are losing this soil water index. Okay, so now we can make a comparison for coffee plantation in Guatemala and Vietnam. For the three regions, we can see that for 2018, we can see here that the northern Guatemala has the lowest soil water index indicator during the rainy seasons of the three studied regions. The northern highline of Guatemala had also a low level NDVI for May. We are also comparing the soil water index with NDVI because it is a very important index for the coffee plantations needs a rainforest to grow to have a good growing. So the NDVI also it is a good measure for the coffee plantation health. Okay, so we can see here that how for the 3 years we can check that for southern Guatemala we are having this this soil water index. Also for 2019 we can see that the lowest index it is for the northern Guatemala. For 2020, which is it is just the beginning of the flower blossom for this year. We have this situation for the southern Guatemala, which is blue. You can see that we have a high soil water index. Both Vietnam and the northern Guatemala they have a low soil water index. So it will be a good idea to keep our surveillance on this on what would happen for this rainy season across across the two regions on both sides of the Pacific Ocean. Okay, so we can my final slide because we have a very short time. I can show you that comparing the NDVI for the 3 years, we can see that Vietnam has the lowest NDVI indicator during the rainy season of the three studied regions, even that Vietnam had a good soil water index. So this is something very important to note, because even if you have a good rainfall, it probably you have a low NDVI. So this probably will create a problem because, as I told you, a coffee plantation needs a good rainforest health to grow to have a good growing and for good crops. Okay, so this is my end of my presentation. I just want to give you another a final note that as I told you, we are having that we're noticing that for example, New Zealand is having a very very heavy problem with droughts during this year. Also, California. This is our data for June 2020, and what makes me a more a concern is that El Nino it is right now like neutral, but there is there has been noticed by the New Zealand Drought Monitor that there is a new El Nino little phenomenon that it is creating on the Pacific Ocean. Okay, so this is like the end of my presentation. I will very gladly if you can give me some questions because we don't have a lot of time, and I will be very glad to answer your question and also to be in contact with you if we can collaborate with some of the data that we have, not just for our regions but also for your regions of interest. Okay, so for me this is my end of my presentation. I don't know if I have to go back to you.
Thank you, Fernando. That's great, and some good ideas for collaboration. So if you've got some questions for Fernando, put them in the question chat, and we'll ask those all together at the end. And if you'd like to collaborate with Fernando, hopefully you will see him in the collaboration session next, session 3 this afternoon. Thanks, Fernando. And now I'd like to introduce Anisora Irimescu to talk about soil moisture data used for environmental monitoring in Romania. Annie, over to you.
Hello. Can you hear me? Can
Hello.
you see the screen?
I can hear you. I can't see your screen yet.
Can you see it now?
Yep. Yep.
Okay.
Presentation mode. Thank you.
Okay. So I'm representing the National Meteorological Administration, and I will start my presentation with a few slides about my institution. What I want to mention is that this year we celebrate 136 years of existence, and we are the founding member of the World Meteorological Organization. So the main activities, we have operational activities related with weather forecasting and research activities related again with numerical modeling, climate prediction, and we also have the remote sensing and GIS laboratory, which I am representing. Our laboratory activities are also related in the field of operational and research activity. And today I will present some of the research activities related with the soil water index for drought monitoring. For this research, we used SAR data obtained from MetoPascat with a spatial resolution of 12.5 kilometers and temporal coverage from 2007 to present. We also use from some research the MetoPascat and Sentinel-1 data, but for today we didn't show you these results because the time period is shortened than the MetoPascat. We also use it some validation data like in situ measurements, air temperature and precipitation recorded at the national weather stations, and agricultural areas obtained from Corin land cover dataset from 2018. So the drought processing flowchart is presented here. So we have the satellite data from the different providers and from Copernicus and NASA and other commercial agencies. We have the data repository, we have the image processing, and we obtain different vegetation indexes and indicators and also the soil moisture. Combined with the agrometeorological in situ data, finally we have the validation and the thematic products like maps or graphs. As mentioned, the soil water index it's at a resolution at 12.5 kilometers and at different depths. It is depending on the crops and the phenology phase. Different depths are needed to be monitored. So here are a few examples of surface skin 0 to 5 centimeters, 0 to 40, and to 1 meter depth. We calculated the soil water index anomaly, which is much more representative and tell us more information about what happened during the time we use it for the analyze. As you can see here are Some are two examples of the soil water index anomaly at the surface, 0 to 5 centimeters, and you can see the eastern and the southern part of Romania, it's suffering already, it's dry. But also at the deepest level, 0 to 100 centimeters, we have some severe drought in the eastern and in the southern part of the country. 2007, it was one of the driest year in Romania. Here are another examples of June 2012 and 2019. So you can see at the surface the anomaly is showing that it is more or less normal, except the eastern part. But in 2019, it is not the same situation. It is more or less a wetter year. The same analyzed, but now for a deeper layer. It's 0 to 100 centimeter. The same area, it's drier in the eastern part in 2012, and in 2019 there are no problem all around the country. So here are other years, more or less the same analysis, just a different 10-day synthesis. Similar with the previous one. And here we did some deeper analysis based only on agricultural area in the Baragan plain, which is this part here. We mark it with red on the map. And as you can see here, we have the 10-day synthesis starting from March to September for the time period 2019. As you can see, the 2027, it's almost red all the year, but lately it becomes blue, which means that it's wetter or normal or wetter than normal. As you can see here, we computed the man candle test, and test Z, it show us that is it's a positive 10. So the soil moisture is improving in the last years. It is more or less the same situation in the 0 to 100 centimeters depth. 2027, it's again very dry, even in such a deep layer. But 2015 and 2018 are very wet, as you can see here. Also, the test show us the positive aspect of the soil water index. So this was the soil water index values, and here we analyze that anomaly. As you can see, the 27, it's a very dry year. At the layer 0 to 5 centimeters. It is the same situation in the 0 to 100 centimeter depth for the same region. What we do need, we do need to convert, to transform the relative values to volumetric units in order to compare with the data we have measured in situ within the weather stations. So here is the formula, and here are some results. As you can see, we use the 10 stations which are in the International Soil Moisture Network, some of them, and measured, done by sensors, and the measures obtained from the satellite data for for 1 kilometer this time from Sentinel-1 and from Metopascat data. And also the results are not so good. As you can see here, we use the porosity method, soil porosity method. As mentioned by Bernard yesterday, there are two methods. One is related with the soil characteristics, especially with the porosity, and the other method is using the cumulative function. And here are the results based on the first method. And here are one day at one station near the surface, and the correlation is also not good, but not so bad. And here are the results for 28th of February this year. The upper map is the relative unit of the soil water index, and the map down here are expressed in the volumetric units. What we plan to validate this transformation with more in situ observation at different depths based on the first method, soil porosity properties. And we also want to see the other method based on cumulative distribution function to see which one is better. And then to correlate the soil water index with other vegetation indexes in order to have a better drought monitoring, but also correlate this information with the precipitation data in order to see if we can better monitor the flood events. And our plans are to have a Copernicus website for Romania based on Copernicus data in the interactive website, but we are just dreaming about it, hopefully to have it very soon. Regarding one of the work we plan to do, here is an analysis of the soil water index on 2 depths and the vegetation health index. And you can see that they are running very good. Correlation is very good. Here it's an increase of the soil water, and vegetation is also responding positive. And also some other correlation of the two indexes. And I am coming to my last slides. It is the current situation. It is presented here 10 days synthesis, one from the last month and first synthesis of July. And you can see that we have had a lot of precipitation in the last month. Not so many in July, and see how the soil water index looks like in 0 to 5 centimeters, which is near the surface. So you can see that here we have some droughty areas, but for 0 to 100 centimeters, the situation is worse. It is the problem we have for the crops for maize and sunflower. They are in the phase that need a lot of water, and as you can see, the water is not so much in this area. So thank you for your attention.
Thank you very much, Anisora. That was fascinating. And now we're going to go back to another question session led by Dr. Gwar Jones. Over to you, Gwar.
Thanks, Lynn, and thanks to all the three speakers for their very interesting presentations. It's great to hear how people are using Earth observation and the Copernicus products in particular in applications. So thank you all three for that. We do have a few questions. The first question that's been asked is a question for all three of you. So I think we'll go to Ricardo first. So to all speakers, have you learned anything during the course of the workshop, listening to Bernard yesterday and other users of the product today, that would make you consider adapting any of your methods in the future? So Ricardo, you first.
Okay, unfortunately, I only today I'm present here, so
Okay.
the presentation of my previous speaker is very interesting, also because we can know about other data sets widespread in Europe also, and we can have a source of data to analyze and to use into our AgraStat platform, I think.
Great. So you learned from presentations that happened today. That's good.
Okay.
So same question to Fernando.
Oh, sorry, I was attending another call. Can you repeat the last question, please?
Yes, I can. So have you learned anything during the course of the workshop, listening to Bernard yesterday and other users of the product today, that would make you consider adapting any of your methods in future?
Oh, yes. Actually, I think that we are working very hard to adapt this data, because we work very heavily with statistics, and we are going to start using this data to generate what we call grouping statistics, to research what are the for example, at the beginning of the rainy seasons, what are the regions that are more resilient to droughts, using grouping statistics. So for sure we are going to use this data for our own, using our own algorithms. Yes, thank you. Yeah.
Great, thank you, Fernando. And then same question to Anisora.
It is a great opportunity for me and for my colleague, which are also present here as delegates, to learn from, especially from Bernard presentation, and to learn about other sensors. In situ sensors are used in other countries, like Cosmos, and of course, we will contact some of them
Yeah.
after the meeting for some more information.
Great. That's exactly what we like to hear. So next question is for Ricardo. How do users use your tool, and is it available outside of Italy?
Unfortunately, the tool is only for Italy, because we start like a National Council Research Institute. We start with the national territory, and then the tool is partially financed by a multinational, a milling and bakery multinational based in Italy. And so the interest is right now for Italy, and maybe for the Mediterranean countries like Spanish, Greece, and of the south of Africa. But nowadays is only for Italy, and the platform is open source, and also the code are open source, so we can exchange information as the delegates and all the potential users want.
Great, that's good to hear. We're an advocate of open source software here at JNCC as well, so it's lovely to hear that others are making their tools available in an open manner. Thank you, Ricardo. The next question is, I think it's for Anisora. How well is the soil water index anomalies, and how well do they work in forest areas?
So as you know, or we in the remote sensing field know that the soil moisture is not good in the forest, and it is not good in the mountains areas. So actually on the Copernicus land monitoring service, there is a confidence mask. We didn't use it here, but most of our analyses are based only on agricultural land.
And you actually, I think, in that question answered another of the question, which was, do you have difficulty with the SWI in particular soils in the mountain regions? And I think I believe you've answered that question there as well. But do you want to say anything else about the mountain areas that's not related to forest?
No, actually for mountains, the difficult thing to monitor, there is no soil, most us know. And the second reason, it is the steep of the slope, so it's difficult to see what exactly it's going on in the mountains. Actually, the SAR data, it's not very good in the mountains areas for any other issue, not just for the soil water.
Yeah, that's true. So SAR data has problems regardless of what application you're using in mountain areas. So next question is for Fernando. Can you use your Earth observation products to predict the impacts of the El Nino events for coffee growers? And can they do something to limit the potential impact?
Well, that's a very high problem. We live here in Guatemala. We live with this problem every day, and I think that there is a need to start, like I told you before, there is a need to start monitoring, but having a very disciplined monitoring of what is happening with the soil moisture and NDVI, not just for coffee but for other crops, because as you can see, El Nino, it is like a very irregular event, because right now we have like a very regular rainy season in 2020, but as you can see before, we have very bad rainy seasons on the 3 years before. So that what I want to transmit is that these irregularities with Mother Nature demands that we start using remote sensing to try to understand what's going on, and for sure we have to take measures on the soil and to complement what Mother Nature was giving us before. Yes, we need remote sensing because these irregularities is like a challenge for all of us. Okay. Yes.
Yes, thanks, Fernando. Next question is for Anisora. Do you consider the SWI data for deep soil layers up to 100 centimeters reliable enough to study moisture in the root area?
I think yes. As far as I know, the maize roots are to about 1 meter, 1 100 centimeters. So I think yes, this is the depth we need to monitor the soil water for the crop, for the maize. And I think, I'm not so sure, but I think also for winter wheat, it is the same situation, but in different months.
Great, thanks, Anisora. Next question for Ricardo. What effect does phenology have on the inferred soil moisture measurement from AgraStat?
So there is the effect of the canopy, and so there is a combination between the crop status and the availability of soil moisture. So I think there is no the measure and the index in our conception, our product has no sense without the presence of the crop. Also because the AgraStat and soil moisture content products were born for the technology transfer, and so our aim is to help farmers, also small farmers, to apply the precision agriculture. So this is the main issue.
Mm-hmm. Great, thank you. I think this question is potentially for all three of you again. So I'll ask the question and we'll see if somebody wants to come in and answer. There is a lot of rescaling of soil moisture from Earth observation. Are there issues with this to do with, e.g., mixture of land use in a pixel or non-linear relationships to your predictor variables? Does anybody want to come in to answer that question?
I can answer.
Great, go ahead.
So in the quantitative measure that we developed in 2020, we try to skip this problem. So we resample and we downscale only one band, and so we try to maintain all the native resolution, for example, for Sentinel-2 scenes, and we decide to opt for the spatial resolution than temporal resolution. So I think that the goal is to maintain the native resolution at 10 meters, so we can skip the downscaling process.
Great, thank you, Ricardo. Anybody else want to comment on that question?
Yes, it is very important to have the same resolution in different indices, soil water, NDVI, leaf area index, and it is also very important to have the resolution with the parcel size. Sometimes in some countries, the parcels are very small, and it is almost impossible to know what kind of crops do you have there. So it's sometimes difficult to say that the index it's telling you exactly the truth.
Yes. Anything to add, Fernando?
Yes, I want to add that from the 1st of July, all the vegetation products of Copernicus are moving from 1 kilometer resolution to 300 meters. So everybody that we work with the raw data from Copernicus will have to adapt all our algorithms, because for sure we have to adapt this resolution. And they say that they will provide an R or a Python tool, but I am not very clear how. So please take notice for this change, because the 1 kilometer resolution that we were using, there will no longer be available for the future for the future data. Okay, so it is very important to take into account this kind of resolution of the data. Okay, yeah.
Great, thanks everybody. Next question, again, I think might be for all of you. How did you hear about the soil wetness index products? Were there any other data products you considered using instead? And what made you choose this one in particular? Who wants to take that first?
I can try.
Go ahead.
Actually, I don't know where from we heard about the soil water index. I think that just looking on the Copernicus websites, we knew about the soil moisture, and the working are done lately for knowing and penetrating the soil in C band, L band, X band, and so on. And we are willing to use all of the data available to see which one is more reliable and for which purpose and so on. So the answer is yes, we can use anything else instead of soil water index as soon as it is available. So since then we are happy with what we have.
Yeah. Anybody else want to comment on that question?
Yes, I can try. Well, soil water index for us, it is very important, because as you can see, the El Nino and the droughts have made a challenge for us as a country, and also the combination of the soil water index with the NVI, because there is this complement between there is no necessary, because you have a high soil moisture, that means that you have a good health for vegetation. Okay, so that's why we combine both indexes for Copernicus. Thank you.
Anything to comment on, Ricardo?
Yes. So like I said before, we try to develop an index in 2018 with the SWI index, but the index was not easily understandable by farmers. So the main goal of our institute is to connect research with end users, and so we developed a new index, the quantitative index. But we have in mind also to in these months to integrate the index with SSM1 products of Copernicus in some way to enhance the overall the temporal resolution.
Great, and then we've got one last question. Again, any of you, I think, can comment on this, because a couple of you have mentioned this. How did you compensate for the low coverage rate of the soil water index? Anybody want to come in to answer that question?
I think that we can more or less improve the coverage, at least at the national level, with the in situ ground measurements. I'm sorry, I am in the National Meteorological Administration, and we also have an agrometeorological laboratory, which has a long time series of soil profile measurements. Maybe not for the soil moisture, soil water, but at least for the temperature, as far as I know.
Great. Anybody else wants to comment on that? No, great. So I think, oh, sorry, Ricardo.
Okay, I think that our main concern is to provide the right information. So we decide to have a high spatial resolution, and for the moment we put in a corner so the SWI product with the high temporal resolutions. Yes, the main concern is the right information for farmers.
Couldn't agree more. Anything to add, Fernando, before we close this session?
No, from my part, thank you very much for the invitation. So I hope that you are doing well, and greetings from Guatemala.
Great, and thank you all three speakers for your presentations and for answering everybody's questions. Back to you, Lynn.
Thank you, Guar, and yes, can I echo Guar's sentiments? Thank you very much for all your interesting presentations and answering all of those questions. I think due to the long afternoon and how much we've been sitting at the computer so far, I think we'll take a short break now and we'll be back at 4:15.